Welcome to BKW Physics. I'm Mr. McConnelly, and we're going to start electrostatics today. And generally, electrostatics is the study of electrical charge, which begs the question, where does all charge come from? So what is the basics of charge? Where does charge start? Like you can shuffle your feet, you can shock your friend, you can send electrical charge or electricity down wires, you can plug things in, your phone, you can recharge it. So where does electrical charge, where does it all start? Think small. Yeah, the atomic level, electrons, and the nucleus. Okay? So, as you can recall from chemistry, you got your nucleus and there's positives there, and then the big of your electrons is traveling around. Well, it doesn't matter what model we're thinking of right now. That's the basis of it. And you will learn later in the year, by the way, just a little side note, that these pieces these constituents that you're thinking of as the smallest things can actually be broken down even further. That's when we do subatomic particles. That's not today. So for right now, just think of there's where charge comes from, there's the basis of it. Now when you have charged objects, when something is charged up, it can be charged up in one of two ways. It can have a deficiency of electrons. In other words, what's another way to say that? It doesn't have enough electrons, so it's got positive. Okay? So if you have a deficiency of electrons, you are positive. And if you have in excess of electrons, you are negative. Now let's start with a really basic concept that you have to understand here. You can't move the protons. Why? They're in the nucleus. Okay? But you can easily displace and move electrons because they're around the outside and they can physically be scraped off, they can be manipulated, you can use other charges to pull them because they're free to move, kind of. Okay? Remember they're in orbitals, so as you get closer to the nucleus, it's harder and harder to pull an electron away because it's just held there better. But the ones on the outside orbitals are very easily manipulated, and the whole basis of electrostatics is really manipulating the negatives that are able to be manipulated, moving them around. Clear? Can't move positives. Get it in your head now, because if you can't get that clear, you're going to mess up things a lot later. Attraction. Unlike charges, attract. Like charges, repel. Simple. So if you got a negative and a negative, it will not like each other. If you've got a negative and a positive, it will be attracted. Alright, we're going to do two demos now. The first demo we're going to do is called a conduction demo. And then we're going to do an induction. Now, at this moment, just watch the demo. Okay, absorb it. And then what we'll do is I have a little note sheet or some diagrams that we'll add to, and we can really see on a small level what's going on with these two demos. So the first one is, and tell me if you can see that from the camera. Even if you move it down, I'm not sure you're going to be able to see it right after. So, I have some fur here, and I have a plastic wand, and I'm going to charge up the plastic wand. Now the way I'm doing this, obviously back to this stuff, I am scraping off excess electrons off of the fur, and I'm collecting them on the rod. Okay, because the rod is made of plastic, which by the way is called an insulator, so the electricity doesn't really want to pass through the wand into my hand. Instead, it just hangs on the plastic here, and if you're in the front row, you can hear every time my finger gets close, it's snapping and crackling because there's quite a bit of static electricity being built up there. I got a lot of negative. Now this thing right here is called an electroscope. That's front and center. And it's got two little pieces, if you can't see from where you're at, if you can't see the two little pieces hanging, kind of moves around so you can. It's got two little pieces of gold foil. It's literally thin aluminum foil, but it's not aluminum, it's gold. It's gold foil. And those pieces of gold foil are used because they transmit the electrons really well. So right now this thing is neutral. The way I know it's neutral, I'm going to have Lou in the front row touch the knob on top. Thanks, Lou. And since if there was any excess of electrons or deficiency of electrons, he has now balanced that out because he's, in comparison, an infinite source of neutral. Okay, because you just have so many of everything, you just balance that thing out. So now, I'm going to go like this. It's a very simple demo. I'm going to bring it over here, and notice even when I get close, it's starting to twitch. We'll talk about that later. But when I touch it, boom, those things go right out, and I pulled it away, and they're still out. They're stuck there, okay? For all intents and purposes, until Lou touches it again, absorbs all those negatives, back to normal, okay? So, I'll do it one more time here. This time we're going to have a cameraman bring it up close so we can see this. So we have a neutral electroscope. Got a good view?
Yes.
Okay. We bring the wand over. You can see some twitching. You touch, and boom. We have charged electroscope. Luke, you ground that again? That's called grounding when he touches it and drains the excess off. That's the first demo. Second demo, let's move this out of the way, but you can stay in the same spot, cameraman, is this one right here. Now again, I'm going to need you to do some things, Luke. So one of these things is, to start out, we're going to neutralize it. So go ahead and neutralize it. And this is called a pith ball. It's like a piece of styrofoam for the best explanation I can give you. So we got this piece of styrofoam, and I'm going to bring this thing close, okay? And it, see, I can kind of affect it because there's some static there. Now I'm going to have you, I'm not going to touch the pith ball. You're going to reach out with your fingertip and touch the pith ball, not my wand though. And as soon as you do that, now the pith ball flies over to my wand and is totally just adhered to my wand. Now if I give this a little bit of time, all of a sudden now, it hates my wand and runs away. Did you catch all that? Alright, let's go. Now you can put the camera back.